Hi, Mrs. Menard here. I'm excited to start the unit of reaction stoic with you guys. This is a unit that really makes chemistry come to life in real world examples. And reaction stoic really takes balanced chemical equations with this idea of the mole and allows you to do some real world problems. So at this point, I would pause the video for just a second so that you can write down the template, and then we will talk through this idea of mole ratios. All right, hopefully you had enough time to write down our example here. When we talk about a mole ratio is a conversion factor. Let me get my pen. A conversion factor it's a conversion factor that we can use to convert from one substance to another using a balanced chemical equation. So, for example, I have this balanced chemical equation here, where if we were going to describe this chemical equation, we would say that 2 molecules of hydrogen reacts with 1 molecule of oxygen to form 2 molecules of water. Well, what if I multiplied everything by 6.022 times 10 to the 23rd? Then I can replace this idea of molecules with the mole. So this is really telling me that 2 moles of hydrogen is going to react with 1 mole of oxygen to form 2 moles of water. So I can get mole ratios from this balanced chemical equation. For example, within this balanced chemical equation, 2 moles of hydrogen is equivalent to 2 moles of water. But we can also say that 1 mole of oxygen is equivalent to 2 moles of water. And because the 2 moles of hydrogen and the 1 mole of oxygen are both equivalent to 2 moles of water, we can say that 2 moles of hydrogen is equivalent to 1 mole of oxygen. So out of this balanced equation, we can convert from any substance to another substance using conversion factors. So we got 3 different conversion factors in this example. All right, so let's look at how we kind of apply this. We want to know how many moles of oxygen are needed to form 3.5 moles of water. Now, I'm sure most of you can do this in your head, but we're really learning the process because we're going to use dimensional analysis to solve this. So we need to start with what we are given. So we are given 3.5 moles of water. We want to get to how many moles of oxygen. So we're really starting here. Here, let me change the color. We're really starting here with water, moles of water, and we want to get to moles of oxygen. So when we're canceling, moles of water can only be canceled by moles of water. So within our balanced chemical equation, 2 moles of water require 1 mole of oxygen. So now my moles of water cancel. I'm in moles of oxygen, which is what I'm looking for. So I'm really taking 3.5 divided by 2, or it would be 1.8 if I am going with significant figures. All right, we can solve the same type of problem looking to see how many moles of hydrogen we need. So 3.5 moles of water, only now we want to get to moles of hydrogen. So let me go ahead and erase where we are and what we're starting with. And now we're starting with water. Come on. My pen shut off. We're starting with water, and we are now going to hydrogen. So again, moles of water can only be canceled with moles of water. So 2 moles of water now require 2 moles of hydrogen. So our mole ratios always come from our balanced chemical equations. Moles of water are going to cancel. And so now we can see that it requires 3.5 moles of hydrogen to form 3.5 moles of water because the mole ratio is 2 to 2. All right, so reaction stoichiometry starts pretty simple with mole ratios. When you're in moles, you can grab a mole ratio out of a balanced chemical equation to convert to any other substance that is involved in that reaction. What I need you to do is I need you to go and pull off the mole ratio practice from Schoology and work through those problems, really concentrating on showing your work using dimensional analysis. All right, as always, if you have any questions, you can go ahead and shoot me an email, and I can help you with whatever you need. So today we're looking at just converting from one substance to another, so it's going to be pretty simple, and it won't take a lot of time. And then the next thing we will tackle is we don't really work in moles, so we'll look and see how we use this when we're working with grams.